Interaction of Color by Josef Albers was first published in 1963. It is a book that is about studying and teaching color in an experiential way. Josef Albers fled Nazi Germany. He was teaching at the Bauhaus School there, which centered on merging art and craft together. And he started to work also at the Black Mountain College and Experimental School in North Carolina during the mid-last century. And he's famous as a colorist and an artist and an educator, mostly dealing with how color is almost never seen as it really is and how it continues to deceive us. So we'll take a look at some of his lessons or studies in this video. And this is the app version of his famous book. It showcases a lot of different examples. Originally, these exercises were done in using colored paper instead of paint to mix colors. So we'll go through some of these exercises here, get us to look at how color is deceiving us. One color looks like two. In our demonstrations that a color has many faces, the first problem is to make one and the same color appear as two, as different colors. The more unbelievably different, the more valuable and instructive. No one is able to see the two centered and framed olive grays as the same color, which is what they really are, physically are. So these two bars in the middle, these olive grays, are the same color, but depending on what's surrounding them, we perceive them differently. Same thing with these smaller little swatches. I'm revealing the middle on the app so you can see it's actually the same color that's going all the way through. Different backgrounds make us perceive those little squares differently. These are just going through a few different examples of this, how a color has many faces. So in reality, it's the same green, but we perceive them, they look different. Same with these browns. Looks lighter on the blue, looks darker on the yellow. And I'm moving them so you can see they're the same color, and then moving out of the background to get a sort of clearer idea of what that color might look like. Ta-da! Here's another sort of part of the book, lighter and or darker, and you can kind of get a sense that same sort of concept as before, even when it's a neutral gray, the value structure is shifting. Here's an example where you have two gradients opposing each other back and forth, and it creates a sort of optical illusion. The background's the same, but that background seems to shift as it approaches the darker or lighter value. Which colors would actually be lighter or darker? That's what this is getting at here. Despite the sort of saturation levels or the value structures between these colors, the hues, if we had to put one next to each other, how could we differentiate which is lighter and which is darker? Are they the same? These are some things we'll be trying out in class. Some more exercises. This is where one color appears as two. Let's read here. Three colors appear as two. One color appears as two, or three colors appear as four. The task, one and the same color, placed equally on two grounds of different colors, is to lose its identity entirely, and not only appear as two colors, but repeat at the same time the colors of the adjacent grounds. As a result, one of the three colors seems to disappear in our perception. The question, what color will act in these two ways? For an easy beginning, each pair of four studies deals with two grounds, which are tints of the same hue. Their lighter values. In each pair, the centers are again of the same color, the same hue, the same color, but the after image changes them to such an extent that they refer to the reciprocal grounds. Thus, three colors are seen as only two. It is more difficult to find that right third color when the grounds are of different hues, and still worse when they are of opposite or near opposite colors. And remember, you're sort of looking in through your periphery. You're not looking at these little swatches of color, these smaller squares. You're sort of looking through them by looking in the middle. That's when it tends to work the best. So look in the middle where that division is between the two grounds. So they're actually the same color. And the idea is that you look in the middle and the little swatches appear to be the color that's opposite of it. The little square looks like the opposite ground. The other little square rectangle looks like the other opposite ground. But in reality, those smaller ones are the same color. Just some more examples to go through. And it's not going to be 100% effective. It's not going to look exactly like the opposite ground, but it looks similar in the least. That X on top of the green is going to look a little bit reddish. The X on top of the red is going to look a little bit greenish. This is a good one here. That X on top of the yellow ground looks a little bit purplish. The X on top of that purple-gray ground looks a little bit yellowish. But they're the same X. A few more examples. So something's happening when we put it on that ground, is creating an effect of the reciprocal ground. Here's another one where two different colors look alike. A new task, two different colors are to look alike, and four colors are to look like three. We consider this color change as color subtraction. In order to present these unusual and little known effects appropriately, first cover the two colors and margins or peripheries of the studies. Then compare the centered small rectangles and find out how equal or similar they look. For a proper comparison, we must see them simultaneously, not alternatingly. The latter way, a repeated looking forth and back, produces changing and disturbing after image, which make a comparison under equal conditions impossible. For simultaneous comparison, therefore, we must focus at center between the two rectangles, and for a sufficient length of time. Now, after the likeness or similarity has been recognized in the centers, uncover the small colored blocks in the margins, and see what the centered small rectangles really are. These two colors were the point of departure for the study. To summarize the problem of the 7 studies in this group, on what grounds will the two different colors shown at the margins look alike or nearly alike? We're mixing color. How are we going to make them look alike or nearly alike? These two colors, the point of departure, are shown either on the different grounds in reverse order, and so emphasizes contrast, or in the least changing placement on the paper ground, which here is white. So let's take a look to see what happens. So remove those little swatches, those keys on the side. So we actually have 4 colors that are supposed to look like 3 colors. 1, 2 colors in the background, that sort of bright pink and the darker blue. And the 2 smaller blocks, in reality, they're 2 different colors. But the trick is trying to make them look like they're the one and single same color. Again, only sort of happening through your periphery, not alternating, looking at one and the other back and forth, but sort of looking through the middle. There's another one. And that key on the side is really important because it shows you how drastic of a change it is from the other one. They might not look very alike, but once you put them close to each other, you realize like how different they are from one another, these little blocks. But back on their ground, they look fairly similar. Not exactly, but put them close together and they're astonishingly different. Same thing here too. Remove the key. Look in the middle, the periphery. They're about the same value structure. And if you can consider that in most of these examples, they're taking that background color and they're sort of desaturating it. Some more examples. It might be a slightly lighter and a slightly more desaturated. This one works pretty good, I feel. Those 2 blocks look pretty similar. But put them on opposite grounds and they are quite different. Pretty close. And the bigger that sort of block is, the less effective the illusion becomes. I think this is one of my favorites coming up, the next one. The blocks aren't that similar, but you bring that other one to the opposite ground and it's strikingly different. But from afar, and separated, they get pretty close. Alright, for a better understanding of why colors read differently from what they really physically are, we show now the cause of most color illusions. On the left, one sees a red circle, and on the right, a white circle, both equally large and similarly placed on a black ground. By staring steadily at the marked center of the red circle for at least half a minute, one soon discovers how difficult it is to keep the eye fixed on one point. After a while, moon-sickle shapes appear, moving along the circle's periphery. In spite of this, one must continue to focus on the red center point in order to assure the desired experience. Suddenly, one shifts the focus to the center of the white circle. Then, from the class, someone usually hears noises which indicate surprise or astonishment. This happens because all normal eyes suddenly see green or blue-green instead of white. This green is the complementary color of red and red-orange. The phenomenon of seeing green, in this case, instead of white, is called after-image. After-image, here's a definition: an illusionary color that appears when the gaze is transferred from concentration on a particular color to a blank, ideally white space. The after-image is the original color's complement, the color opposite on the color wheel. It's kind of like a burn. So the phenomenon of seeing green, in this case, instead of white, is called an after-image, or simultaneous contrast. Simultaneous contrast, the tendency of adjacent colors to shift in color toward each other's complement. A gray on a red ground will look green. On a green ground, it will look red. Adjacent colors that are complements will intensify each other. If a green and a red lie next to each other, a green will look greener and a red will look redder. Albers uses the term as a synonym for after-image. So after-image and simultaneous contrast are synonyms. They sort of mean the same thing. So when you put a color on a ground, that ground is going to suck its likeness and sort of amplify what it is different about it. And the second one, after the red circle, are a series of yellow circles. Same sort of effect with an after-image. A plausible explanation to all this? One theory maintains that the nerve ends on the human retina, rods and cones, are tuned to receive any of the three primary colors, red, yellow, and blue, which constitute all colors. Staring at red will fatigue the red sensitive parts so that with a sudden shift to white, which again consists of red, yellow, and blue, only the mixture of yellow and blue occurs because the red has been absorbed or tired. And this is green, the complement of red. The fact that the after-image or simultaneous contrast is a psychophysiological phenomenon should prove that no normal eye, not even the most trained one, is foolproof against color deception. He who claims to see colors independent of their illusionary changes fools only themselves, no one else. The red circle will appear for about a minute, and then it will automatically switch to the white circle, and you'll see that shift turn to a cyan circle. Ta-da! Here's the other version if you want to go through it. See what happens when you stare at this set of yellow circles for a while. What color do you see afterwards, and where are those colors occurring? Check out the app. Go check out the book in the library. We'll try some examples similar to these in class. See ya!